Okay, so let's do practice quiz 4, question 4. So in question 3, we found the regression line. It was 95 over 86x plus 10 equals y was our regression line. So in question 4 here, we have to find the RSE for the regression line. So let's do that. So to find the RSE, or the residual standard error, let's first find the residuals. So recall how to do that. So the residuals is the scatterplot y minus predicted y from line, and here our line is this guy here. Okay, so let's start doing the predicted y values. Okay, so again we're using this line to find our predicted y values, and the x values we're going to be using will be 18, that's the scatterplot x, the 22, and the 46. So let's do the predicted y value when x is 18. So you're going to put 18 in place of x right here. So that's what I've done here. So it'll be 95 times 18 over 86 plus 10. And you can check in your calculator that's roughly equal to 29.88. Okay, so that's our first predicted y value. Let's do the predicted y value next when x is, say, 22. So doing that one we get then. Okay, so doing the predicted value when x is 22, so I'm using this x value here. So I'm plugging into my regression line, which is right here. So in place of x, I'm going to put 22. So it'll be 95 times x, which is 22 over 86 plus 10. And that's roughly equal to 34.3. And lastly, let's do the predicted y value when x is 46. Okay, so doing that we get then, so putting 46 in place of x right here. So it'll be 95 times 46 over 86 plus 10, which you can check is roughly 60.81. Okay, now let's do the residuals. Let me just actually make these guys a bit smaller so I can fit more on here. Let's make it, say 12. Okay, so let's do the residuals now. So doing that, we get then, let me just actually move this around here a bit. Put that here. Okay, so for first residual, let's do the this one here. So the scatterplot y for 46 is 60, so it's going to be 60 minus the predicted y value with 46, which is 60.81. And we'll come back to that in a second. And then going on to the next one, let's do the 40 guy. That's the scatterplot y value corresponding to 22. So it'll be scatterplot y value is 40 minus the predicted y value when x is 22 is 34.3. And lastly, the scatterplot y corresponding to 18 would be 25, the y value here would be 25. And the predicted y value when x is 18 is 29.88. Okay, so working these out, you can see they're actually, all these are fairly close, but they're not perfect, but they're very close. So working these out, we get then, okay, so you can check that 60 minus 60.81 is negative 0.81, and 40 minus 34.3 is 5.7, and 25 minus 29.88 is negative 4.88. So now let's find the RSE. So recall the definition here. Here's a definition of the RSE, the residual standard error. So in our case, n is 3. Case n equals 3. So, and we're just going to square this number, square this number, square this number, add them together, take square root, divide by n minus 2. So doing that, we get then, so doing that, so we're going to square the negative 4.88, which I've done here, square the 5.7, which I've done here, square the negative 0.81, which I've done here, take square root and divide by 3 minus 2. So I'll let you check when you work this out. The inside becomes 56.96, and the square root of 56.96 is roughly 7.58. This is the RSE for our regression line. So for our regression line. Okay. So regression line is y equals 95 over 86x plus 10. So we found it was 7.58. Okay, let's recall what the RSE was for the first line we had. So recall that. So recall from question 2, we found this line 5x plus 130 over 6, and we found the RSE for that line was 11.66. These are all relative to our scatter plot, which is the main scatter plot values here. And I mentioned earlier, I think last video, that the regression line gives the smallest RSE for your scatter plot. So you can see this RSE was 7.58, and the one for this line was 11.66. So you cannot beat 7.58. That's the smallest RSE for this scatter plot. So if you are able to come up with a smaller RSE for the scatter plot, I'll give you an A in the class. But of course, that's an impossible task I'm giving you, because it's not possible to come up with a line that has a smaller RSE than 7.58 for these scatter plot values. Okay, so we're done with the question anyway. So we found our RSE. Let's now do the next question on the practice quiz. Okay, so here's the 5th question on the practice quiz, the last question. It says use the regression line, I should say here, line as a model to predict how many Facebook friends a 34-year-old man should have. Okay, so how we can think of the regression line as a model is the x here. So in the scatter plot, the x is corresponding to ages, and the y is corresponding to Facebook friends. So we can write the regression line like the following. So the y then would be number of friends, and the x is age. If you look at the scatter plot, the 46 is the age, the 60 is number of friends, 20 is the age, 40 number of friends, and so forth. So on our model then, regression line model here, the y would correspond to number of friends, the x would correspond to age. So if you want to know how many Facebook friends a man has, then you just go, this is just a model, roughly equal to 95 times age divided by 86, plus 10. So we want to now let the age be 34. So let's find our predicted number of friends when age is 34. You're going to put 34 in place of age here. So doing that, we get then. So putting 34 in place of the age here, then it'll be 95 times 34 over 86 plus 10. And let you check, that's roughly equal to 47.56. Okay, so let's write our conclusion. Okay, so here's our conclusion. Oops. So hence our regression line model predicts that a 34-year-old man should have about, you round this up to say 48. So about 48 Facebook friends. Okay, so we're done with the question. We're done with the practice quiz, so I'm going to leave the video here. So we're done.